In light of the fact we weren't able to complete all of the slides in our PowerPoint this class, I've created a small video to help you review the concepts from dimensional analysis. This will be a challenging topic for some. However, others have indicated that they have experience with dimensional analysis and just require a little bit more practice. What did come out as a consistent theme among most students was that many students say that they struggled with the word problems or the case scenario based questions. When you have a case scenario or word problem, you need to pull out the most important or relevant information from the problem. Sometimes we include distractors, so there'll be information in the problem that you need in order to solve and information in the problem that you do not need. You'll need to ask yourself 4 questions. What is it you're being asked to give? Is it a liquid? Is it a solid? Is it milligrams? Is it milliliters? What is available or on hand from the pharmacy? How is it stored or stocked? And what is the physician's order? What is the patient supposed to receive? Are they supposed to receive 12 milligrams or 50 milligrams? And do you need to perform any conversions? And if so, you'll remember the mnemonic we discussed in class that began with King Henry. Let's move forward. If you would like to follow along with the textbook, currently we are looking at page 270. Obviously, we need to start with identifying the unit of measurement that we are looking for in the calculation. Perhaps we're looking for milligrams. Perhaps we're looking for milliliters. Second, we need to set up our equation. On the left side of the equal sign, we are going to put the appropriate abbreviation for X. Maybe that's a tablet. So in this case, we want to know how many tablets to give. Next, we'll need to begin setting up information in the equation side of the calculation. In this problem, the available dosage is 1 tablet equals 20 milligrams. So in this problem, each tablet contains 20 milligrams. You would set up the equation like this. 1 tablet, keeping the desired unit, tablet, on the top, 20 milligrams. Next, you'll put a multiplication sign and another fraction. From there, we would start with what the doctor ordered, 40 milligrams, over 1. You can put anything that's by itself over top of 1. At this point, we would cancel the like terms, milligrams and milligrams, and we would only be left with tablet. If we were left with any other measure of unit, then our calculation or equation is set up incorrectly, or we're missing information. So now that we're left with tablet, we can do simple multiplication. 1 times 40 equals 40. 20 times 1 equals 20. And again, carry over your tablet, so you would want to write tablet over here, and 40 divided by 20 is simply, I'm hoping you said, 2. In this scenario, you would give 2 tablets in order to give the doctor's dosage of 40 milligrams. Let's look at another example. The doctor orders Dilaudid 5 milligrams in a tablet form, PO-TID. Knowing and understanding medical terminology, we understand that PO means per orum or by mouth, and TID means 3 times a day. So this client will get 5 milligrams 3 times a day. But what you have available in the medication cupboard is Dilaudid 2.5 milligrams per tablet. So each tablet contains 2.5 milligrams. How many tablets are you going to give in order to administer the safe dose of Dilaudid 5 milligrams? Setting up your equation, on the left side, you would put X tablets. That's what we want to learn. Then you're going to use your equal sign, and then you're going to enter the information that you know from the word problem above in an equation format on the right side of the equal sign. We know that each tablet contains 2.5 milligrams, so we can put that in a fraction format. remembering to keep, most importantly, the tab at the top. If that's what you're solving for, keep it on the top. Then you're going to put a multiplication sign, another fraction, and the dose that we're looking for is 5 milligrams. So we'll write in 5 milligrams. Remember, you have to write in your measured or your units. And you can put it over 1 because anything by itself can be placed in a fraction format over 1. From that point on, we simply solve for, from that point on, we simply cross out our units, milligrams and milligrams, and we're only left with tab. So we know now that our equation is set up appropriately. So 1 times 5 equals 5. 2.5 times 1 equals 2.5. So there we go. I need to write my measurement or unit. And 5 divided by 2.5 should equal 2 tablets. If, however, I write my answer with just a 2, then I can expect that I will be marked wrong on the math test. You need to write out 2 tablets. So you need to write out 2 tablets or 2 tabs. Let's look at an example using a medication label. Quite often in case scenario questions, you'll be given information in a Word format, but you may also be given a label that you'll have to read and interpret. Right here, we'll find that the medication is supplied, Lasix, 40 milligrams per 5 milliliters. Over here, we would write that down in the dose available, or dose on hand. The physician has ordered Lasix furosemide 20 milligrams PO daily. And I hope that you understand that PO means by mouth. That may be in a liquid format or in a tablet format. Right now, because we're dealing with a liquid, we know that we're looking for milliliters. How many milliliters will the nurse give the patient in order to administer a dose of 20 milligrams? Step 2, setting up our equation, we would leave ml on the top of our fraction as we carry this over, or in the numerator position, because that is the desired unit that we are looking for. If you start with this equation in the correct spot, you'll come up with the wrong answer. So milliliters must stay on top because that's what we are looking for. Next, we know that the dose, 20 milligrams, is all by itself. And on the last slide, we said whenever you have something all by itself, you can put it in the numerator position over 1. So in a fraction format, it would be 20 milligrams over 1. Do we need to do any conversions? No, because our units, milligrams and milligrams, are the same. Let's move forward. Begin by canceling out your labeled units, milligrams, leaving you with only milliliters. At this point, if that's the only unit of measurement in the equation, you know you can begin calculating. 5 times 20 will equal 100. 40 times 1 will equal 40. When you divide 100 by 40, you're left with 2.5 ml or milliliters. Therefore, the nurse will administer or draw up 2.5 milliliters of solution or liquid in order to administer the dose of 20 milligrams to the patient. There will also be times when you'll have a choice between a solid pill medication and a liquid version of the same medication. The dose will always be the same. It's whatever the doctor or nurse practitioner ordered. However, the milligrams per tablet and the milligrams per mil will be different. Why don't you try and solve for these problems and share the results with a friend? Here's an example where a medication can come in either format. It can come in a pill format or a liquid format. Here are 2 examples of how those medications would be supplied. Take a few moments, pause the video, and try to complete these steps, setting up the equation the way that we just set up the equation in the last 2 examples. You can check your answers with a colleague, or you can bring them to class and we'll discuss them. Alright, please see your textbook on page 273 and complete the following questions. Take some time and practice setting up the equations so that you'll have success when you write your test and when you perform drug calculations in clinical. Please remember that you can check your answers and each step of the setup in the textbook. All of the answers are provided for you. Please double check that you're setting up your medication questions correctly. After you've had some time with practice, come back to the video and let's continue moving forward. Please don't move forward unless you've had some time to practice the exercises mentioned on the previous slide. After you've done this and had some success, let's move forward. If you're struggling with any of this, please connect with the nursing tutors in the nursing lab. Let's look at an example where conversion will be required. Quite often in nursing, you'll have to read a case scenario and perform a conversion of some sort. Here's a typical example of a relatively easy one. The doctor orders ampicillin 0.5 grams PO daily. What's available is ampicillin 250 milligrams per milliliter. So what we need to figure out is how many milliliters will the nurse draw up or administer in order to achieve this dose of 0.5 grams of ampicillin. Our first step is to set up our equation. We know that we're looking for milliliters, so we'll start with X milliliter. Then we'll begin with our equal sign and setting up our first fraction. We know that in each milliliter, and we'll keep that on the top, there is 250 milligrams. So that will be our first fraction. The next step is to perform conversions. From our discussion in class today, we remember that every gram contains 1,000 milligrams. That's something you should commit to memory. That'll be a conversion you'll be doing quite often. Next, you'll want to carry over the doctor's order. In this scenario, the doctor has called for ampicillin 0.5 grams PO daily. At this point, it looks like we're ready to begin canceling out our units. So you'll cancel out grams, so those will disappear. You will cancel out milligrams, so those will disappear. And the only unit of measurement left is or should be ml, milliliters, which is what we're trying to solve for. Now we'll perform our steps. 1,000 times 0.5 milliliters equals 500, and 250 times 1 equals 250. That should really be underneath the 500. When we perform our division, we're left with an answer of 2 milliliters. 500 divided by 250 is 2. And we carry over our unit of measurement, milliliters. Therefore, the nurse will draw up or administer 2 milliliters in order to give a dose of 0.5 grams. If the nurse drew up a lower amount, the patient would not get enough medication. If the nurse drew up more than 2 milliliters, the patient would be overdosed or receive too much medication. So let's practice. The doctor has ordered 0.2 milligrams of a levothyroxine, a medication for the thyroid, and the pharmacy has available 100 micrograms. Notice how the two units of measurement are not the same, and therefore you'll need to do conversion. Pause the screen, set up your dimensional analysis question, and try to solve for the number of tablets you will administer. When you're done, bring your answer to class and we can discuss it. Let's practice some more. Please open up your textbook to page 275 and complete the following questions. You'll want to become very comfortable with setting up dimensional analysis questions and solving for the number of milligrams, tablets, or milliliters you will need to administer in order to administer medications safely in the clinical setting. Please keep in mind that if you understand how to solve for problems using other formats, that's perfectly acceptable to check your answers to ensure that they are correct, but we need to see your work on a math test. If you would like to watch more, here's a link for a YouTube video created by a former nursing student who does an excellent job explaining dimensional analysis.